I hope you guys are enjoying your long weekend. We are picking up with video tutorials day 3, and we are almost at the end here, so we'll have one more tomorrow. But this first section, okay, coterminal angles. If you remember, coterminal angles are angles that end in the same position. So if I have my axes here, and I'm referring to a 30-degree angle. If I add a full rotation, so let's say I go around the circle twice, or once, one full, but we're going to end in the same position. Okay, well that full circle that I went around is another 360 degrees. So the red angle that I drew in is actually a 390 degree angle. But notice how they still have that same terminal. We call that a terminal or an ending side. So this side here is in the same position as the green 30-degree angle. So both the 30-degree angle and the 390-degree angle are called coterminal angles. So the reasoning behind it is that they end in the same position because they are just an extra rotation of each other. So angles that end in the same position. In other words, they have the same terminal side. So if I were to say, how do we figure out coterminal angles? You'd say that you need to add or subtract 360. And that's because that extra rotation is a full circle, which is 360 degrees. But if I'm in radian mode, remember 360 degrees is the same thing as 2 pi. So it depends on whether we're working with degrees or whether we're working with radians. So now the second part of this, they say list at least 4 angles that are coterminal with 210 degrees. So we start in degrees. We want to stay with degrees. So I can take 210 and add 360 degrees, add another 360 degrees. Okay, so there's 2. Or I could take 210 and I can subtract 360 degrees and do the same thing again for another rotation. So here we have 4 angles that are all coterminal with 210. And there we have our 4 angles coterminal with 210. Okay, now converting is a little bit different than coterminal. Converting means that we're not getting an extra rotation and we're keeping the same angle. So we're still dealing with a 210-degree angle, but now we want the radian measure. So it's kind of like saying 12 inches or 1 foot. They're still the same exact measure, they're just in different units. So we want to cancel out the degree measure. So if I want to cancel, remember from stoichiometry, we want to put degrees in the bottom, and we're just putting its equivalent measure in the top but in radian mode. So 180 is equivalent to pi. Same thing here. We're going to cancel our degrees by putting it in the bottom and putting pi in the top. Now, let your calculator do the work for you guys. You have them to use on your final. So all you're doing is you're saying 210 divided by 180, math, enter, enter. Negative 120 divided by 180, math, enter, enter. All right, so we're using our calculator as much as we can so that we can save a little bit of time for where we need it on the final. So I just need to go back and put pi in here. So I'm going to say 7 pi over 6 and negative 2 pi over 3. All right, reference angle is another new topic. So these are all kind of, they look similar, but they are meaning totally different things. Reference angle means that I want an acute angle using this angle here. So 11 pi over 4. We have to figure out where is 11 pi over 4. Well, this is 4 pi over 4, because that would reduce to 1 pi. This is 8 pi over 4. Okay, so I'm adding 4 each time. So 4, this is 8 pi over 4. If I add another 4 on top of 8, 8 plus 4 is 12 pi over 4. So this is also 12 pi over 4 in this location if I add another. So 12 pi over 4 would be 1 bigger than the 11 pi over 4. And if you remember, your pi over 4s are all of those angles that are in the middle here. So if this is 12 pi over 4 right here, then the one right before it is the 11 pi over 4. And all I'm doing now is I want to know what is this acute angle right here that I'm highlighting. Well, I got to do 12 pi over 4 minus 11 pi over 4, and I get pi over 4. Similarly, we're going to take 17 pi over 6 to figure out where that is. Keep in mind this is 6 pi over 6 because that reduces to 1 pi. 12 pi over 6. So each time we're adding a 6 in the top. So if I add another 6 in the top, that would be 18 pi over 6. Okay, so I'm just an extra rotation around when I get to that. So remember, 6 plus 6 is 12, 12 plus 6 is 18. So I'm over here now. And keep in mind I'm going this way as I work my way around. Now pi over 6s, all of the ones that have a 6 in the bottom are those ones that are close to those axes. So we call those the short triangles. Well, if this is 18 pi over 6 on the x-axis, then the one right before it is the 17 pi over 6. And what I want to do is I want to take those to figure out this acute angle that comes between them, the one that I'm shading. I'm just subtracting them to get 1 pi over 6.